Welcome today to today's webinar. The topic, of course, is writing reusable Zen Framework 2 modules. So the module system in Zen Framework is actually a layer that sits on top of the MVC. The MVC is completely unaware of modules. Basically, a module is simply going to group related functionality that you want to expose in your application somehow. When you do that, basically our bootstrapping mechanism goes and finds out about your modules and it grabs configuration, does some tasks, and then gives this information on to the application layer. And the application layer at that point is really just going to be taking a look at the things like the router and the locator in order to figure out what to do with things. Hold on a second, I see a window just popped up. I'm in a Windows virtual machine that I don't use often, so every now and then I'm going to have pop-ups, I'm sure, about updates happening and all of that. So I apologize in advance. I was hoping to do this off my normal desktop. So getting back to the modules, basically, why would you want to create a module in the first place? And like I said before, the module is a way to group related functionality. We've got the start of an ecosystem in Zen Framework 2 already surrounding modules, and this includes, for instance, a user module. Why would you want this over, for instance, just ZenDoth? Well, what it does is it provides you with the integration with the MVC, so it gives you controllers for registering users, for logging a user in, logging a user out, persisting that user's identity throughout the application in a way that you can access it. And so that's all related functionality. It's one discrete task. Another module that I've created, for instance, is for my personal blog, and that blog module provides basically just that information. How do I get to the data persistence layer, and how do I get to the various entries in the blog? How do I list things by tag, that sort of thing? But that's all it does. So what these modules do is give you a way to really take discrete areas of your application, break them down into something that you can maintain easily, and hopefully then reuse and distribute to others so that they can use them. So what is a module exactly? Modules in Zen Framework 2 are typically really a namespace, a PHP namespace. You're going to say everything under this is mine, and this is how I'm going to access it and qualify it, and it's using that namespace. Typically, within Zen Framework 2, a module also contains at least one single class file called module, and it'll be under that namespace. The reason that we have this is basically to ensure that an easy way to integrate with the MVC application. Now, if you don't need to integrate, if you're just providing a library, for instance, you wouldn't necessarily need this module class. But what the module class does is it helps you to scaffold certain things like auto-loading, things like configuration, event listeners, that sort of thing. So if you need to do any of those things, you provide this module class. Now, I alluded to this already, but modules can contain really anything. They can contain PHP code, and typically you will have PHP code, especially if you're doing anything with the MVC. This is where you will put your MVC code. Unlike Zen Framework 1, where we had that application directory, and then basically everything under there was assumed to be MVC, and that you grouped everything together in one place. The idea with Zen Framework 2 is that you will group related functionality in modules, and that related functionality will often include the MVC code, such as controllers and views and that sort of thing. But you can also have a lot of other things in modules, assets such as your cascading style sheets and JavaScript and your images. You can have unit tests. In fact, we encourage you doing unit tests, especially if you're doing any sort of library code within your modules. You want to have the tests in there so that people can run those and make sure that everything runs the way they expect. If you're going to be redistributing it, you probably want documentation of some sort. So you'll have your documentation within the module so it's all in one place. But really, you can have anything you want in your modules. I've created a module, for instance, called Skeleton CSS. Skeleton from getskeleton.org or .com, I can't remember which one it is a responsive CSS framework. And I use it within my, my web application for my website. And what I do with this is I ship it as a module. And that allows me to take it and drop it into whichever application I'm using and automatically expose it. there's a question that just came in is, how can I serve that information because it's not in the public directory? There's ways around this. The way I do it currently is I actually take the application, I take my Apache configuration, and I use alias matching in order to take a path to, for instance, a CSS asset and match it to a public asset within one of my modules. And it's a really easy 1 or 2 line addition to your Apache configuration. You could also use tools that would then move the your assets into the public directory, that sort of thing. But the point is that I can ship them in a way that I can reuse them in other applications without necessarily needing to grab that library code, figure out where to drop it into my application, that sort of thing. It's just bundled. So at the most basic, I've got my module directory in my application, and under that I'll have a number of different modules. Now these are going to be modules that I am developing. If they are third-party modules, I'll put them in my vendor directory. But in my module directory, I have my modules, and for instance, I've got a foo module, and you'll see a module.php. That's all I need. Inside that is a single class named module in the namespace foo. Now, this isn't going to be very helpful, and it's not going to do really anything at this point. Our module loader will go and find it and say, oh, wow, there's nothing that's happening in here, but hey, we've got a module named foo. Great. So typically, we want to do a little bit more than this. Our recommended directory structure for a module looks a bit like this. So we have the module name. That's usually going to have a one-to-one correspondence with the actual namespace for our module. We'll have our module.php file in there. We'll have a config directory for module-specific configuration, and we'll go over this in detail. A public directory sometimes will be in there, and if you have a public directory, that's where you'll put assets that you want to serve out of the document root. So these include CSS, images, JavaScript, that sort of thing. Our source directory is going to have actual PHP code that we want to use. The test directory, the unit tests, and view is going to be for things like templates and that sort of thing. Now, some people ask about the source directory, and they say, well, why do we need to have this additional level of indirection here? Because as you'll see, the module namespace is repeated in there, and the code is under that. The reason is because we want to have each of these directories basically are having specific concerns that they're dealing with. We don't want to be mixing up a PHP code with CSS, with view scripts, with tests, and that sort of thing. We want to keep them segregated. By segregating them, we can also ensure that we can follow PSR 0 guidelines, which state that there should be a one-to-one relationship between the directory structure and the actual code that you're trying to invoke. By having the source directory, we can point our autoloader to that directory, and everything under there should load automatically using a PSR 0 autoloader. So that's a common question that we have. It's one of those things that seems really, at first when you're going, oh, why do I need to do this? But as you start using it and you start adding more and more to your module, you'll see that having a specific place for everything in there and it makes it so that you don't have to make those decisions yourself. They're already made for you. It's code, it goes here, it's under this namespace, boom, I'm done. So again, this is a recommended module structure. You can actually put it any way that you want to. It's up to you then to indicate how to find things. So for instance, autoloading, if you use a different module structure, you just have your autoloader do the work that it needs to do in order to load the classes and the code within your module. Same thing for configuration. If you put it in a different location or use different conventions, you simply in your module.php will inform how to get that and pass it back. We do recommend, however, that you stick to this structure, especially when redistributing, because it will make it very easy for other developers to go and read your module and review the code and understand where everything is and how it all works. So the things that we typically provide, I mentioned this before, are auto-loading artifacts, basic configuration, including your roots, and event listener registration. So these are the three ways basically that you hook into your MVC application. You have to tell it where to find the code. You have to tell it how the code relates to each other and inform how to use some of the code. So that's your configuration. And then your event listeners are going to be, how do I tie into the workflow of the MVC? So providing autoloader hints. This is pretty easy. Basically, there's an interface called the autoloader provider under Zen Module Consumer. And that defines a single method that you need to implement within your class, and that's getAutoloaderConfig. Now, some things that we've done within the autoloaders within Zen Framework 2 is that we have an autoloader factory that accepts the an associative array of autoloader names and their configuration. One of the things that we've also done was we've made it so that as you pass more configuration to it, if it sees that, hey, I've loaded this autoloader before, it simply adds the configuration to that existing autoloader. So what this means is that each one of our autoloaders can pass in this information, and it's just defining the autoloaders that already exist. So if we have a class map autoloader, we're just adding classes to that class map. If we are using the standard autoloader, which is our PSR0 implementation, we're adding namespaces to it. What this does is it means that we don't have a plethora of autoloaders running at any given time. We've got one or two, maybe three, and they're configured iteratively so that as we load more and more modules, they're getting more and more configuration in order to do the work they need to do. What that also means is that the autoloader config method can simply return configuration for the autoloader without actually doing anything. In this case, our foo module is going to provide configuration for the class map autoloader. That includes a class map file. It's basically going to include the class map file from our current module, and that's going to be passed as options to the class map autoloader. Additionally, we will tell the standard autoloader that for the foo namespace, we want it to look in our source directory under the foo subdirectory of that module. Now, configuration is slightly different. We're going to see a lot of examples of configuration as we go. But typically, all you want to do is return an array or an iterator or that you can pass to the config class. What's going to happen is that this will then get merged with other configuration that happens. The nice part about this is that it means that we can basically build up a large amount of configuration for a single class built out of the configurations from each of the modules. What that usually means is that we can simply include a PHP configuration directly out of our module, and it's going to get merged in with the rest of it. So you'll see here that our getConfig method is going to simply include a PHP file and return the contents. So that actual configuration file just returns an array. That's it. Now this one, we don't use an interface, so something that will change in beta 4. But right now, if you just simply define a getConfig method, there's a listener that will see if that exists, and if so, it's going to go ahead and call it and take the whatever is returned from it and merge it with the configuration that it's building. We'll see examples of configuration shortly. Now, a typical module configuration, here it is right here. I forgot the order of my own slides. So in this case, we've got a module configuration here. Typically, what you're going to be configuring right now is the DI container, the dependency injection container. So in this case, what we're going to do is we're going to basically provide it some routes, and that's it. We're going to say, hey, we are tying into the MVC. We are going to provide a controller that we want to have invoked at some point based on a certain route match. So what we do here is we tell it to configure the route stack, and we give it the routes parameter. What's nice about this, again, is that this will merge with the configuration for the route stack from other modules, which allows us to build up the entire route stack that we want to be looking through when we are matching our routes at the application level. So we're defining a foo route here. That's a literal route, and it's going to match on /foo. And when it does, it wants to use the controller, foo controller, index controller. We're telling it that it can have child roots, but it can also be the last. It doesn't have to have child roots in this particular case. So that's 14 and 15, lines 14 and 15 in this slide. We won't look at further configuration of this because we'll see a more complex example later as we build a module. So this is a very standard thing that you're going to do right here. The other thing that you will often do is, if your controller has dependencies, you'll define those dependencies here as well. You may also want to define things like configuration for some of the various default listeners that are provided. You may want some module-specific configuration that you want to grab out and use later, that sort of thing. But this is the most typical example, is configuring your routes. Now, I mentioned there were 3 things that we do typically with modules. The first one was auto-loading configuration. Second is your actual application configuration. The third was event registration. So typically what you will do is you'll grab your static event manager and tell it that you want to listen to the Bootstrap event. And what that does is it allows us to say, once all of the modules are loaded, I need to do some additional configuration, or I need to do some other stuff. So that's our lines 7 through 14 on the slide. Now lines 16 through 21 are the actual listener. And what's really cool here is once we listen on that Bootstrap event, we actually have access to the application. So we can say app equals E, which is our event object, get param application. Once we have the application, we have access to the locator, or DI instance, so we can say get locator. We have access to the configuration, so we can say get config. With those 2 things, we basically have access to everything in the MVC lifecycle. So at that point, we can do whatever we want, and we can shape the lifecycle however we need to do. So this is a very common pattern that you're going to see within MVC, and within modules that communicate with the MVC. Now, something that comes up often in questions is, how do I register module-specific event listeners? If there's something I want to do only when a particular event is triggered, how do I do that? The way that we do that is basically you want to register with the route event, and we want to do it at low priority. And this slide actually gets cut off a little bit, but if I scroll over a little bit, line 10, you'll see it's registering at a -100 priority. What that means is after routing has happened, I want to do something. This module check method that I've done right here is going to go and it's going to grab the route match out of the event. The MVC event defines this get route match method. And from that, I'm going to grab the controller. Now, line 17 is where the magic happens. If the start of the controller doesn't match my namespace, I'm not going to do anything. But if it does, at that point, we know that the controller matched is one that I'm actually interested in. It's something that my module is going to do something with. And so at that point, we can start doing cool stuff. So this is a pattern that you'll also see quite often within modules, is that we want to do initialization, we want to do a customization of the workflow only if we know that our module was selected. This is something we were never really able to do in ZF Framework 1. So this is really neat. Jesse Hernandez asks why the event manager passed to the module send method. Why it can't be passed there instead of using a singleton. This is a slight design flaw right now. The event manager in the Bootstrap is not the same as the one that's in the application. Additionally, if you want to be able to tie into events that are on different controllers that you may not actually have access to right at this moment, you want to use the static event manager so that you can say, hey, if this context is ever pulled and it triggers this event, I'm interested in listening to it. But I don't have access to that instance yet. The instance may not actually exist. Now, that said, we're probably going to make some changes for Beta 4 in order to make this story work a little bit better. And there's a way that we can do it with the dependency injection, and Ralph and I are working on it right now. So some of the static stuff may not look quite like this, but the same patterns are going to apply. You're going to register with the Bootstrap. You're going to register then with, with the route event. You're going to register with the dispatch event, that sort of thing. So the same ideas apply. Whether or not it's a singleton is something that will still be decided as we move on in the development of the framework before we go stable. Doug Beerer asks at this point, in ZF1 terms, is this like a front controller plugin where you can check for module name, controller name? Yes. When we are attaching to the event manager instance from the application object, and we register with route or dispatch, and we can do it with high or low priority, this is very similar to doing like pre-route, post-route, or a route startup, route shutdown, and dispatch loop startup and dispatch loop shutdown. This is very similar to that in ZF1. The difference is that we're using an event manager with a priority queue. The nice part about this as well is that we're using the same pattern throughout. So if I want to attach to the controller, I can do that and attach in the same way, but it's to that specific instance, which is really nice. And so that would be more like the how the action helpers work when they do pre- and post-dispatch events. Moving on. So registering modules with the application. So once we've created our module, we still have to inform the application about it. So the config/application.config.php, so this is at the root of your application. We need to go in there and update the modules array to add our module to the list. And that's going to be the namespace we use. It's the name of the directory that we use for the module. We just add that in there. So in this particular example, we would have added foo. And at line 6 is what we would have done. So you have to remember to do that. That's the one part that's a kind of a gotcha with people is they'll develop the modules and they'll go to test it and they're like, well, why can't I get there? And the reason is most likely they forgot to add the module to the application. Adding it to the directory is one thing. It's another thing entirely to inform the application that it exists. We are doing this way. We're making it explicit because we want people to be thinking about what they expose. We don't want people to just assume things are going to work, in large part because sometimes they may drop something in and then no longer use it, but it's still hanging out there. We want them to be able to look at it and go, hey, these are the actual modules that are in use. Do we need these? If there are any, we can cut them. They don't even need to remove it from the source control. They can just update this configuration. So let's get our hands dirty. We're going to develop a module today. We're going to go through, I'm going to show as much of the code as I can. Some of the code is hard to do on single slides. So, I'll split it across multiple slides. At the end, I will have a link to a Git repository that you can go to that has the full example. And it's a full working example. I can actually show it on the screen if we need to when we get there. And I may actually do it to show some configuration changes as we go. So this is a module for building a contact form, really simple thing. Our goal is to display the contact form. We're going to validate it and then redisplay it if necessary. So if it's invalid, we want to redisplay it. And then we're going to send an email via a configured mail transport and display the thank you page. Very simple, a very simple workflow. I usually like to work in terms of, what am I going to be displaying to the users? So I start from there. Now the first thing that we would do is we go into our skeleton application. We'd make our directory for our module, so I'm calling it module/flycontact. I go into there, and I'm going to make a few directories. So I create a config directory, a source fly contact directory, a view/contact directory, and we go from there. So we have a very basic module structure. The other thing we can do is we have a Zen skeleton module in the Zen Framework organization's GitHub repositories that you can actually grab and use that as the foundation. You, of course, have to rename the module and the class underneath it, but it's a really great way to get started. So like I said, I'd like to start off with what do I actually need to display to the user. So I'm going to have a contact form, and I'm going to have, of course, when I process the contact form, and if it's invalid, I need to display that. And I also need to display the thank you page when we get done. So I'm going to start with a base root. Now, the cool part about the MVC implementation of ZF2 is that the router is a tree-based router, which means that we can have basically a bunch of children and grandchildren and other descendants of a single root. This makes it really easy to, first off, make very simple little bits of configuration for each root. It also makes it very easy to have a base root that you can then use via configuration change where it directs. And I'm going to show that after we get done with this example here. Our base root here we're calling contact, and it's a literal root. We're having it listen to /contact. Very easy. And when it gets, if it matches, we want to use a controller, fly contact /controller/contact controller. So we're going to use this as the base controller that we have within here. And when we match this, we'll go to the index action. And this is going to be very similar to ZF1. If you were to say, /contact and you had a contact controller, they would use the index action. So it's the same idea here. The only difference is that we're being very literal about it. We're saying, and explicit, we're saying, hey, this is the exact controller we want, and this is the action. This is something that I consider best practice, and there's been a lot of discussion about it. A lot of people are wanting the kind of magic routing that we have in Zen Framework 1. We'll likely add something like that, but I'd like to show an example like this because it shows the power of the router. The other thing is that by doing it this way, you get your 404 page that much faster. It doesn't have to go through as much work. It doesn't actually have to pull out a controller when something doesn't match. Basically, if we don't match, great, we just return a 404 page. We don't have to do anything else. So that's my philosophy on it. That said, we will likely have a magic route of some sort, 4 modules that you can drop in and say, hey, this is the module name, this is the start of the route that I want to use, and here's the namespace and prefix that I want to use for this particular module when I invoke a controller. So we've got this base route. This is our beginning of our configuration for the module, and we are now matching contact. Now when we process the form, we want to process. So I'm going to create a process route that's going to be a child route of the base contact route. So you'll notice line 2, I say this is a child route. And the previous slide on line 16, we start defining child routes. So this would be a subarray of that. Again, I'm going to do a literal type here, and it's going to listen to /process. So what will happen is /contact/process will be the actual match that we do. And at this point, the action we want is process. It will inherit the controller from the parent root if we don't specify one. So we know already that we'll get our contact controller, which is awesome. And now we'll use our process action in there. Our thank you page is also going to be a child root, again, of the base contact root. And in this case, it's also literal, and it's going to listen to /thank you. And so it will be /contact/thank you will be the full match. And we'll specify the action here as thank-you. Now, we know that, and we also know we're going to have a form of some sort. And we'll build that controller in a minute, but let's have the routing in place. Let's have our form ready. The form is going to define an email, going to define the subject. The body that we want to actually have is the body of the email. CAPTCHA, so that we can kind of prevent spam coming in. You know, if they have felt the CAPTCHA, hopefully that means that they won't be able, they're human of some sort, not some bot. We'll also have CSRF protection via the hash element so that we don't have iframes and stuff coming in. And then a submit button, obviously. I'm not actually going to show the entire form here, except for a little bit of work on the CAPTCHA so that we can make sure it can be injected. So our contact form, we're going to override the constructor. The constructor normally takes an array of options. In this case, we're going to set it to null, and we're going to check and see if, and actually I just realized there is a slight problem here. Line 15 should actually read CAPTCHA adapter and not options. But if CAPTCHA adapter is an instance of the CAPTCHA adapter, then we are going to call a method, a setter called setCAPTCHA adapter, and we're going to pass it in. And then we're going to initialize with basically an empty array or a null object. Otherwise, we'll pass the options specified by CAPTCHA adapter on in so that we can keep going. There's a couple typos on the slide. I'll correct them up on the website when we get done. But the basic idea is that we're saying that we cannot use the form without a CAPTCHA adapter. The setCAPTCHA adapter is simply going to take that and assign it to a protected member, and that's it. And within the init method, so those of you familiar with Zen Framework 1, init method gets called after the constructor is complete. And at that point is when we usually set up all the elements for the form. So one of the elements I'll do is adding a CAPTCHA, and I'll specify that the CAPTCHA parameter to this element is going to be the CAPTCHA adapter that we specified in the constructor. So that's about it. So the rest of it is, again, up on the GitHub repository that I'll link at the end of this tutorial so that you can see how it works. But I wanted to show this because we're going to be using that CAPTCHA adapter. We're going to be defining it in our dependency injection configuration later. Now, Contact controller. The fun part about ZF2 is that instead of having to load up every single dependency across your entire application at the start of every single request, is that instead we match the route and then we pull the controller. And because we're pulling the controller from the dependency injection container, we can define the dependencies directly on our controller so that we only get the dependencies we need for this request. So we need to specify a few dependencies on our contact controller. Now, one of them we know already is the contact form, which we just defined. So we're going to say that we want to do that. So we're going to define a setter for that, set contact form. The other things that we're going to be doing are a mail transport, because obviously we want to send an email, right? So we need a mail transport. So that's going to be a dependency of this contact controller as well. The other thing is that we want to have a base message, and the reason why is that we want to be able to specify who it's getting sent to and who the sender is, so that when we send this email that comes into our inbox that we want, instead of some random one that who knows where it came from. So we're going to have these as dependencies. By adding setters to this, we can then add a little bit of DI configuration and get these injected as soon as we pull this contact controller, so that when it needs to do its work, it has the dependencies it needs. So the first one is to display the form. And so the index action is simply going to return an associative array with a form key. And we can just simply say this form. And the reason we can say this is that we know the DI container is going to take care of injecting the form object that we need. And so by the time we get to this point in the application, we know that we already have it. To process the form, we have to do a little bit more work. First, we don't want to process it if we didn't get a post request. That's line 4. The other thing is if that's the case, we want to set the status code to 302, which is saying, hey, this is a temporary redirect. And we want to set the headers to header line to location to contact. Actually, at this point, we should also return the response at this point. And in the actual code I have, that's what happens is after line 7, we would say return only this response. So basically what we're doing here is we're saying, hey, let's redirect. We're going to go back to the contact form. Now, if we have a post, then we're going to actually try and validate it. So we'll grab the post variables and cast them to an array. We'll grab our form, and we'll check to see if the form is valid. That's line 11. If it's not valid, then we need to redisplay the form. So what we do here is something that we can do now as of beta 3. We create a view model, and we set the error variable to true. We pass in the form, and then we set the template on the view model to be contact/index. So what we're saying here is we want to display the same view that we did in our index action, and then we return that model. So what happens is if the form is invalid, we redisplay the form, and that's all that happens. Otherwise, we'll go and send the email. We'll grab the values out of the form, and we'll send an email. And after that, we'll redirect to the contact/thank you page. And when we say to root here, you'll notice that we're using contact/. The slash is going to separate the child roots. So the contact was the base root. Thank you was the child root. And so we do contact/ to concatenate them. The router knows what to do with that and will create the appropriate URL string for us. So pretty easy here. Now, next thing we're going to do is send the email. So that what we're doing here is we're going to grab that data that from the form, we're passing it to the send email. What we do at this point is we grab the from, subject, and body off of the out of the form, and we set those to variables. And we take the message that we injected into the controller, and we add the from, the reply to, the subject, and the body, and then we tell the transport to send it. We have a question in the Q&A. Somebody's asking about seeing the BI configuration for this. We will be seeing that. I just wanted to show that what the controller looks like before we do that. So at this point, we know that we've got a message where you're adding some states to the message, and we send the message via the transport. The final action in this controller is the thank you page. And this one we're going to do a couple of checks. we want to look at our headers and see if we have a referrer header. If we don't have that, or if it doesn't match /contact, then we're going to say, hey, you came to this illegally. We should really only be getting to this from the contact page. And if so, we change the status code to 302. The default status code for the redirect helper is 301, so we're doing this manually here. We add our header line, and then we return the response. Otherwise, we do nothing. And by returning an empty array, we will be triggering a view to actually create a view model and have it resolve to via the default rules, which will say controller/tank-u. Our view scripts are pretty easy. This is the one for displaying the form. This is contact/index.html, which you can see in line 2. We add a head title. We prepend the contact to that, and then we create a section in here, which is going to be contact me. And at this point, I just realized that we are missing the end section. I think that's correct in the repository. But we check to see first if we have an error. If so, we display an error, and we give them a nice little error message. And if not, we don't display that portion. And then at the very end, we grab the form. We set the URL to use the contact/process route. So URL uses routes by default. And we set the method to post, and then we render the form. And that's it. Very simple. Thank you page is static, basically. We're going to prepend contact and thank you to the title, so it'll say thank you. And then we just have this nice little section here, and that's it. Static HTML. Now, DI configuration, and this is where the fun stuff comes in. So the first thing is we're going to do the DI configuration for the form. And as we mentioned before, we wanted to pass in a CAPTCHA adapter as a required parameter to it. So we're going to say that the constructor is required and that we are requiring that the CAPTCHA adapter parameter be present because it does have a default of null. And we're going to say that the type has to be a Zend CAPTCHA adapter. So this is an interface that we're typing on, so we can actually tell it exactly which interface we want to use. It also means that if we get something that does not satisfy that interface, DI is actually going to tell us that before it actually tries to instantiate anything. The message is something interesting. Now what we have to do here is we have to provide a DI definition. And so you'll see lines 2 and 3, I talked about this. We need to have a sub-array of DI called definition. And what we're going to do here is we're going to say for the Zend mail message, we want to define some configuration for the add to, add from, and set sender methods. And what we're saying is we want to add in the email or address list and name for each of these. And they're not required, but we want them to be injected and we want to allow scalars. And that's what the type of false is to allow a scalar value for that particular element. This is kind of messy because I needed to make it so it fit on one slide. It's more readable in the GitHub repository. But the basic idea, again, here is we're defining injection points for the message itself. We're going to define a preference for the transport, and that's going to be the SMTP transport. We're actually going to override this so that we can test it. But we set the preference here so that by default it's going to try and do that. It'll use the default settings for the SMTP transport unless we provide otherwise. For the contact form, then we will say in the for the DI instance, we're going to say that we are going to use the Zend CAPTCHA dumb CAPTCHA adapter, and this is one that simply prints out a random string and that tells you to type it in backwards. The contact controller, we're telling it that we want the form to be injected and we want to use the contact form. Since we didn't type in on contact form, this ensures that it gets injected correctly. So the full DI configuration is over these 3 or 4 slides here. Now for the view scripts, we are going to do a couple things. There are 2 different ways that you can set up view script resolution, the template map resolver and the template path stack. The map resolver takes a map parameter and it basically takes the template name and maps it to a specific file. The template path stack says, okay, I'm going to take a paths parameter and that's going to be an array of different paths, and one of those might be, for instance, the view directory of my module. I like to define both of them. The reason being that by defining the template map resolver, it becomes really easy for somebody to override a specific template. They can simply change the configuration and change the map to look at a specific file. This is also really, really fast. So this is a good thing. We create an autoloader map, and the way we do this is we change directory into the module, and we then say simply php // vendors and framework bin class map generator.php. And let me just see here. And we're going to tell it to that the source directory is where we want to look for the library, and we want to output this to autoload classmap.php within the module itself. Now the autoloading, we're going to set up our module class at this point. And I mentioned before the get autoloader config method, and this looks basically the same as we had before. The only difference is that the standard autoloader, we're now looking at the fly contact namespace. So we're going to say that's the namespace we want to look at, and we look under the source fly contact directory of this module, and that's it. For the configuration, of course, we want to grab our configuration. That's what we've been defining, so we simply include config/module.config.php, and we're done with that. We're not actually doing any tying into the event manager at this point, so I don't have to show anything else from the module .php file at this point. We're only going to do autoloader configuration and the configuration for the application at this point. Now, we've defined the module configuration, but most likely we want to be able to override that at the application level. And so you can actually do that right now. If you place configuration files in the config/autoload directory, it will actually look for these. I see another typo on this one. Line 2 should actually say .local.config.php, and that's the way it is in the directory, what do you call it, the Git repository. What we're going to do here is we're going to define our own preferences and our own instance information. Line 8 is incorrect, and actually we don't need to do that. Actually, line 8 is interesting. That should be fly contact/controller/contact controller. Obviously, I should have proofread these one last time. But what we do here is we're going to say the transport is going to be the file mail transport. And the reason that we're doing this is that I want to just simply log them to a temporary directory so that I can take a look and make sure everything's working correct the way I expect it to. The other things I do is in line 18 and 19, I set the email address for the add to and set sender to something that I can actually test. I'm using here what's called the disambiguation technique for parameters. And this takes the name of the class and the method and the parameter that you want to utilize. And it ensures that if there are parameters that are named the same in the class, that you can ensure that they're getting injected to the appropriate place. Now, as I said before, we have to add the module to the application, so I'm adding fly contact in line 6 there. Very easy. We saw that example earlier. And when we visit the page, this is what we end up getting. I am actually going to show what this looks like. Actually, I can't because I'm not on the right machine. So never mind. But the idea here is, I can't get to the code does work. If we go to contact, it will do this. If we were to go contact/thank-u and just go directly to it, it will actually redirect to this page. If we try and enter everything in, it will try and process the page and display validation errors. So this will work great. I'm sorry I can't demonstrate this to you. Like I said, I had the last minute switch from my normal workstation to a Windows VM so I can do the presentation, and I don't have hosts set up correctly on here for you to actually visualize it. So I mentioned, the title of this is creating reusable Zen Framework 2 modules, and I want to explain why it's reusable. So I mentioned that we can override things at the application level by taking our configuration file and modifying things. So one of the things we could do is we could change the base route. So you'll notice here, line 8, I'm changing that to /contact us, and I don't have to do anything else with this particular key. I can actually close it out at this point. It'll get merged cleanly, but now the root will be contact-us. Very nice. So this is reusable. I can drop it into another application, and if I want the contact form to be in a different location, I simply change the configuration of that base root, and now everything continues to work. Again, why is it reusable? We can change the mail transport and the default messages. If I want to use the SMTP transport, I can change that preference. If I want to use a send mail transport, I can change that preference. I can change the message parameters so that I can use a different email address for the to and the sender. So I can use you at your TLD instead of me at mwop.net. So we can override the configuration at this point in order to get different behavior from the application. Another thing we can do is I can change the CAPTCHA. And so instead of using the dumb CAPTCHA, I could use reCAPTCHA. Now clearly I'd want to specify further configuration like my API key and that sort of thing. But I can do all of that if I want to through the configuration. So I now have this module that stands alone that I can drop into any one of my applications, and I can use some configuration, the DI configuration, in order to change the behavior or change how it responds slightly without actually having to touch the code itself, just configuration. So I'm just going to review what we did when we created our module. We created roots. We created application assets, in this particular case a form. I say kind of because we didn't go through the entire thing in here. We created a controller that has different endpoints for landing, processing, displaying the thank you page, that sort of thing. We could have created multiple controllers if we needed to. I just showed one here because it's an hour-long webinar. We created the necessary views for our application. We set up the DI configuration for the form, for the controller, for the mail transport and message. And then we created our module class, and we created an autoloader class mapped that into our module class and set up the configuration for autoloading and for the application itself. And we added the module to the application. It's very easy. It's a nice, simple workflow. The nice thing I like about using modules is it forces me not to think about, how does this tie in over here and all this. It forces me to think, okay, what is this particular problem I need to solve right now? And encapsulating it in a single location so that I can go and look at everything at once for that particular part of the application. Really good example of this, Evan Khoury is on the Q&A. He developed ZF2 User along with a number of other contributors to the project. It's doing one thing really well, and it's how do I log in a user, how do I register users, how can I do that with a variety of different backends, and then how can I inform the rest of the application about this user. It does that one thing, and we're not looking at, how do I integrate this and everything else. We can use the listeners for that. And that way we don't have to monkey patch code. We can just drop this in and configure it and do what we need to do. So this is what I'm loving about modules at this stage. There's a lot of resources. The contact module that I did today, the full code for this is up on GitHub under my name, and it's flycontact is the name of the repository, fly_contact. This presentation is actually already online. I'm going to go and tweak it after this to correct some of the things that I saw in there. But this URL will continue to work. mwop.net/slides/20. Actually, that should be 2012. Damn it. Sorry about that. 2012-03-14-ZF2 Modules, ZF2module.html. ZF2 subsite, framework.zen.com/ZF2 for every bit of knowledge that you need about Zen Framework 2. This is a good place to go. If it's not right there, it's linked from there. If you're interested in modules that can be reused, there's also modules.zenframework.com. And you may want to go to the ZF Commons GitHub organization because there's a number of them that are currently under development there as well. I'm going to answer QA, and then we'll end off this webinar. I'm just checking to see if there's anything I didn't show. Fernando Crespo asks why the contact form is not in a /form folder inside the module folder. Actually, technically, it should probably be under source/flycontact/form with capital F so that we maintain things. I did it as just under the top level because there's really only 2 classes in this particular module. There's really no need to go deeper. In fact, we didn't even really need the controller directory. But if I were to do it so that every, like all the forms are grouped together via / capital F form in my source directory and the namespace for the module. Evan Corey notes, the configuration that I show here is all using nested arrays. You can use other formats. Right now in Beta 3, we support INI and XML as well. And basically what you can do is you create your config object and you return it, and then it will merge it with the main application configuration. We will be getting support for JSON and YAML again, but we rewrote things in Beta 3 for the configuration, and so those adapters will be coming in Beta 4. Looking through the questions some more. Looks like the ones before that I answered. There's another one at the end. Rob Allen is asking what the preferences does in the BI config. So what preferences does is it says, when I encounter this class name or this interface name when I'm preparing injections, use this particular class, this particular implementation. So for instance, if we type hint on the GenMail transport adapter, it will say, if I set the preference for that to SMTP, it will say, okay, when I encounter this type hint, I want to use the SMTP adapter specifically. Anton Schwartz is asking, do I have any tips for creating config files that are needed in a multi-site, single-source site? No, I don't have any off the top of my head. I think I need to understand the question a little bit better. If you are interested, if you have questions about Zen Framework 2, the best places to go are the ZF-contributors list, mailing list, and also ZF-Talk.2 in Freenode IRC. There's always people in there who can answer questions. And then the last question here, I'm going to take, this is going to be the last one before I cut off for today. I'm sorry, I do not know how to pronounce your name. I think it's Zimishir. But he's asking, what is the best way to organize and standardize common features between modules? So ACL, auth, etc. And he's asking, is events the appropriate way? So if you take a look at ZFC user, and then there's a new ZFC ACL component that's being developed as well. What happens with these is they set up the basic MVC infrastructure, but then they set up listeners that will go and listen to certain things. So for instance, if you need to have an area that is password protected, you can hint to the ZFC user, if I remember correctly, and it will say, oh, a password is required for this area. We don't actually have a registered user, so now I'm going to send back a login page. ACLs, basically what we would do with these is quite often define the ACLs and provide a way to build the ACLs out of some sort of definition, and then tell the locator that, hey, use this when you need to, when a particular class needs an ACL instance. So it's a combination of using events and BI in strategic ways so that you can accomplish what you need to get done. The nice part, again, is because we have these two systems, it makes it really easy to create something that is going to work across the, without modification as we go. It looks like there may be one last question. I'm waiting for it to show up in the Q&A. Maybe it went into the chat area. Lucian Pacquier is asking, where's the message and mail transport injected into the contact controller? In this particular case, we've defined the message and the mail transport. Basically, when we defined the contact controller, we told it that we needed the form, the transport, and the message. And if you look in the repository, you'll see that it's defining all those in the BI configuration for it. So it will happen because we simply defined those parameters within the DI configuration. And because the DI is able to figure out what the types are, it will understand what to inject at that point. So I hope you were able to learn something from this today. I hope you're going to go forth and start writing Zen Framework 2 modules, and that we're going to see them out in the wild, and so that I can start using them in my website. So have a great day, everybody, and thanks for joining today.